This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will finish connecting the transformer primaries to the hot and neutral lines through the AC power connector. From the circuit diagram, we have the AC power connector coming into the lower half of the enclosure. There are three toroidal transformers, the first one to be used for 0 to 20 volt, the second one used for the dual tracking minus 20 to 0 to plus 20 volt power supply, and the third toroidal transformer to be used for the digital supplies, plus 5 and plus 3.3. In all cases, the primaries are connected in parallel to the 120 volt line that I have in this apartment. If I were working off 240 volts, I would be connecting these primaries in series. The leads to the toroidal transformers are wired strands, and on the primary side, I don't want those leads too long. They're carrying 120 volts, and we don't need any unnecessary electromagnetic interference. So the first thing I'm going to do is trim these leads. I'm trying to get as short a length as I can. Let's cut these all to a workable length. And now we got to strip each wire to a rather long length, because I'm setting this up to twist these wires together as appropriate. Luckily, two of these transformers are the same manufacturer, and therefore the color coding is consistent. The third transformer, the ones with the yellow jacket, different manufacturer and different color coding. And now we got to make sure that the polarities of the wires twisted together is appropriate, so that the windings are acting to support one another as opposed to opposing one another. And those are two sets of windings of the same manufacturer. I don't know what's going to happen with this project, and I may need to take things apart and possibly reuse some of these transformers, so I'm kind of reluctant to do anything permanently at this point. At some point, I'm going to conclude that there are no major changes to be made, and I'll start eliminating some of these connections and apply some more solder. What you don't see is I've got reference sheets off to the side, and I'm consulting the color coding of these things. I don't want to get the color coding wrong. If I do, I'm going to wind up with magnetic fields in opposition to one another if I hook up the primaries wrong. And that'll lead to little or no secondary voltage and a very hot, if not melted down, transformer. Now there's the third transformer, which is a different manufacturer. And again, I'm checking to make sure that the polarity of these primaries is the same. Now we have the two primaries, and each one of these transformers, if you recall from the circuit diagram, have two primaries. And I'm connecting both of these primaries together, and now I'm connecting primaries to each other. Primaries of different transformers need to be of the same polarity? No, I don't think it makes a difference. Okay. Last set of wires. And now I've got a gaggle of transformer primary windings for the toroidal transformers, twisted together as appropriate. Now I need to cut some wires to length for the hot and neutral lines coming from the AC power connector. Cut these to appropriate length. And strip those. I already have some quick disconnects attached to the power connector. Okay, so now we're connecting the hot line and neutral line to the two groups of toroidal transformer primaries. Hot line connected, and now the neutral. And tighten up on these twists with the needle nose pliers. Rather dull needle. Now I'm using a wire nut. These are spring-loaded wire nuts, and that's the critical part of it. You start twisting these on, the spring grabs on to the copper and forces the wire into the nut. The resulting connection is rather strong and dependable. I've never seen them fail. Okay, now let's connect to the traditional transformer, first connecting the neutral lines. And this transformer has two primaries and therefore two connections to neutral and two connections to the hot line. Now there's one more connection that needs to be made from the AC power connector, and that is to connect chassis ground to the lower half of the enclosure. I'm using one of the mounting screws of the traditional transformer as a good place to stick on the chassis ground. Hopefully it'll prevent some of the electromagnetic interference of that traditional transformer, which could give me some headaches along the way downstream, but for now it's a convenient transformer to have. Now the last piece of this, in terms of construction anyway, is to attach the AC power connector to the lower half of the enclosure. washers, lock washer, and now nut. Attach that relatively hand tight. I don't want things attached too tight because I know I'm going to have to take these things apart several times in the course of developing this. It's just the way I'm developing it. I don't like to do everything at once. I do incremental development. And now I've got the top half of the enclosure connected to the bottom half of the enclosure. I've got to be careful about this. This is necessary, and I'm trying to do it in as safe a manner as I can. I am now in a position to turn the power switch on. So here are the actual voltages of the secondaries, and so far so good. Here's the second half of the secondary. I'm trying to record these things as I go. I'm not going to show every single measurement because I'm not sure I recorded every single measurement, but I will publish the revised circuit diagram with the accurate voltages. The voltages here tend to be a little higher than the manufacturer's specifications. That should be 12. It's 14.3. They're all about anywhere from 10% to 20% higher than the manufacturer's RMS readings. Now, what I'm doing is working off of this DVM, which is actually measuring average voltages, actually absolute value averages, and converting to RMS. All right, so things seem to work, astonishing as that might seem. In this video, I trimmed and stripped primary leads to the toroidal transformers, twisted primary wires of common polarity together and to the requisite hot and neutral lines, connected hot and neutral lines to the traditional transformer, attached chassis ground to the lower half of the enclosure, attached the lower AC power connector shell to the lower half of the enclosure, and tested all the secondaries, recording their actual voltages. In the next video, we'll be working on rectification and filtering of secondary voltages. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.